First question, write the following in decimal form and say what kind of decimal expansion each has. First one, 36 by 100. We know that 36, when you are dividing by 100, straight away we can write that as just move 2 places to left. It will become 0.36. In the 36 by 100, we can write as 0.36. This is the terminating decimal form. So we can write that as terminating decimal. That means 36 by 100 is a terminating decimal. Second number, 1 by 11. First we have to look at how to divide 1 by 11. 0 point, when you are adding 0, it will not go on 10. So again you have to put on top 0. And adding 0, it will become 9 times 11, 99, remainder is 1, 10, again 0, again add 0 here, 9 times, it will come 99, 1. So you can see that 1 is repeating. So we can write that as 0.0909, etc. It is going on. That means 0.09 bar. Here the remainder 1 is repeating. So we can write that as 0.09 bar, and this one it is non-terminating recurring decimal. Non-terminating recurring, repeating, recurring decimal. Now the third number, that is 4 and 1 by 8. 4 and 1 by 8 to mixed fraction, so we can convert that into proper fraction. 33, 8 into 4, 32 plus 1, 33 by 8. Then you have to divide 33 by 8. When you are dividing that 4 times 32, remainder 1, 10, 1 time 8, 2, 20, 2 times 16, 4, 40, 5 times. Now we got the remainder as 0. If the remainder is 0, remainder we got that as 0. That means it is the terminating decimal. So we can write that as terminating decimal. Now next one, it is 3 by 13. Fourth question, 3 by 13. When you are dividing 3 by 13, same way, first you have to put 0 and add 0 on the right side of 330 and continue the normal division. When you are doing the division, we will get 0 point, the block of numbers, digits are repeating. That means 2, 3, 0, 7, 6, 9. This block you can see that is repeating. This block of numbers is repeating. That means 3 by 13 is equal to 0.230769. Again 230769. It is continuing like that way. So we can write 3 by 13 is a what type of decimal? Non-terminating recurring decimal. Non-terminating, it's not terminating. Non-terminating recurring decimal. First question, fifth word, 2 by 11. 2 by 11. When we are dividing 2 by 11, 0 point, adding 0 in 21 times, then 9 is the remainder, then 98 times 88, remainder is 2. So remainder is again repeating. 2, it was the beginning and that is repeating. That means the answer, it will come 0.181818, etc. We can write that as 0.18 bar. 18, that block is repeating. So we can write 2 by 11 is non-terminating and repeating decimal. is non-terminating and repeating decimal form. So 2 by 11 is non-terminating repeating decimal. Sixth one, 329 divided by 400. 329 divided by 400. So 329 divided by 400, when we are dividing, what we are getting? 0.8225. 0.8225. And it is terminating. Remainder as 0. That means terminating. Second question, we know that 1 by 7 is equal to 0.142857. That is repeating. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, etc. are without actually doing the long division. Without doing the long division or without doing the division, from this we have to find the value of or decimal expansion of 2 by 7, 3 by 7, etc. It is given that 1 by 7 is equal to 0.142857 as a group or a block of digits are there. Now from that 2 by 7, we know that 2 by 7 means is equal to 2 into 1 by 7, which is equal to 2 into, we can put the value of 1 by 7 here, 0.142857. So the number when you are putting here and multiply each digit by 2, 142,857, 0. Into 2. When you are multiplying, you will get 0.285714. Same way 3 by 7 is equal to 3 into 1 by 7, which is equal to 3 into 0.142857. Multiply and get the answer. 4 by 7 is equal to 4 into 1 by 7, which is equal to same way 5 by 7. 5 by 7 is equal to 5 into 1 by 7, and 6 by 7 is equal to 6 into 1 by 7. Just apply the value of 1 by 7 there, and when you are multiplying, you will get the answer. Same way, when we are multiplying one value of 1 by 7 by 3, 4, 5, 6, we will get the numbers like the same way. You can check your answer. Question number 3. Express the following in the form of P by Q, where P and Q are integers and Q not equal to 0. First one, 0.6 bar. 6 bar means 0. That digit is repeating. 6, 6, etc. It is going on that. So first step means we have to take, we just assume let x is equal to the given number. That means 0.66, etc. We can write 0.6 bar also here in place of that anyway. And then multiply this by 10. When you are multiplying both the side of this equation by 10, this we can mark as equation number 1. When you are multiplying by 10, what we are getting? Equation number 1 into 10 gives 10x is equal to, on the right side when you are multiplying one digit it will come to left. That means 6 point, again that 6 is going on. So this is we can mark equation number 2. Now we are going to subtract equation number 1 from 2. Equation number 2 minus 1. When you are minusing left side 10x minus x, it will become 10x minus x is equal to, on the right side, 6.6 bar minus 6 bar. This part, decimal part, that will cancel. When you are subtracting 6 minus 6 everywhere, it will come 0. So you can cancel that one. Then remaining 6 minus 0, that means 6 itself. So 10x minus x means 9x, which is equal to 6. From that, we will get x is equal to 6 by 9. When you are simplifying that, it will become, you can divide by 3, it will become 2 by 3. That means x is equal to 2 by 3. That's the answer. Now, second number is 0.47 bar. 0.47 bar. That means 0.4. This bar is on top of 7 only, not on top of 4. That means 4 is not repeating only one time and 7 is repeating like the same way. So here also same way, let x is equal to 0, the given number 0.47 bar. Then multiply that equation number 1. When you are multiplying the equation number 1 by 10, we will get 10x is equal to, multiplying on the right side by 10, it will become 4.7 bar. That equation number 2. Again, equation number 2 into 10 gives, when you are multiplying left side with the 10, it will become 100x. When you are multiplying on the right side, 7 bar means 7, 7, 7, etc. So when you are multiplying by 10, 1, 7 we have to take to left. That means 47 point. Again 7, it's continuing, repeating. So we can write 47.7 bar. That is equation number 3. Now we are going to subtract 2 from 3. That means equation number 3 minus 2 gives, what is coming here? 100 minus x. Left side it will come 100x minus 10x is equal to, on the right side, 47.7 bar minus 4.7 bar. That means 47.7 bar minus 4.7 bar. When you are minusing that, the 7 bar decimal part, it will come 0. Then 47 minus 4, what we are getting? 43. So when you are subtracting this side, we will get 43. That when we are writing, we can write that only the decimal part, it will become 0. So 47 minus 4. 100x minus 10x means 90x is equal to 43. Which means x is equal to 43 by 90. Third question, 0.001 bar. We know that 0.001 bar means that all these 3 digits are repeating. 0.001, again 001, 001, etc. It's going on that way. First we have to take, let x is equal to the given number 0.001 bar. Then what we have to do? 3 digits are there repeating. So multiply by 10. This is equation number 1. Equation number 1 into 1000. Which gives, when you are multiplying left side with 1000, it will become 1000x is equal to, when you are multiplying right side by 1000, 3 places you have to move. 1, 2, 3. That means 1.001, it will be like that way continuing. So in this side, we can write that as 1.001 bar. This 001 bar, 1 is repeating. All these 3 digits is continuously repeating. When you are multiplying by 10, one place it will have to move to right, by 100, then 2 places. Here we are multiplying by 1000, then we have to move 1, 2, 3 places. The decimal point, it will come over here. And then 001 is repeating. So it will become 1.001. And that we can write as 1.001 bar. And this is equation number 2. Here also just 2 minus, equation number 2 minus 1 gives, here this side 1000x, so 1000x minus, left side of first equation, that is x, is equal to, on the right side, 1.001 bar minus 0.001 bar. So this decimal part will cancel. 1000x minus x will become 999. X is equal to 1, which gives x is equal to 1 by 999. That's the answer. Now question number 4. Express 0.999 etc. in the form of p by q. So let x is equal to 0.99 etc. That is equation number 1. Here only one digit is repeating. So multiply equation number 1 by 10. It will become 10x is equal to, take one digit to left, 9.99 etc. That is equation number 2. Now 2 minus 1, equation number 2 minus 1, 10x minus x, it will become 9x on the left side and right side. This decimal part it will cancel, then 9 minus 0, 9. That means x is equal to 9 by 9, which is equal to 1, which implies the answer x is equal to 1 itself. Why then are you surprised by your answer? With your teacher and classmates discuss why the answer makes the sense. That means 0.99 etc. which means it's almost near to 1. It's going to very close to 1. That's why we are getting the answer x is equal to 1. Question number 5. What can the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? 1 by 17. That you have to divide 1 by 17. So just do the division and get the quotient. So the number 1 by 17. When we are dividing 1 by 17, we are getting such a big block of number. In this block, it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. After 16 digits, then again that is repeating. The first number is repeating. So we are considering all these digits together as a block. So that's the answer. Question number 6. Look at several examples of rational numbers in the form p by q, where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? We can go through 2-3 examples. First one, 5 by 8. 5 by 8, when we are writing in decimal expansion form, what we will get? 0.625. Here q is equal to, that means in the form of p by q, q is the denominator, q is equal to 8 and that 8 we can write as 2 cube. Another example, 4 by 5. 4 by 5 is equal to 0.8. Here q is equal to 5, that means 5 raised to 1. Another example, 7 by 10 is equal to 0.7. Here q is equal to 10 and that we can write as 2 into 5 with power 1. These all expansions or fractions, when we are converting to decimal form, that is terminating decimal. So what is the speciality or what property the denominator is following? We can see that it is in the form of p by q. Q is the denominator. Here in the first example, q is equal to 8, that we can write as 2 cube. Second, 5, we can write 5 raised to 1. Next, 2 raised to 1 into 5 raised to 1. That means when we are looking different examples, we can see that the terminating decimal always, when we are doing the prime factorization of the denominator of the given fraction, when we are doing the prime factorization of the denominator, that means the value of q of the given questions or given fractions, always we will get the power of only 2 or only 5 or both. That is the condition. That means when we are doing the prime factorization of the denominator of the given fraction, if we are getting the denominators as the power of 2 or power of 5 or both, then we can say the given fractions are terminating. Question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. Non-terminating, non-recurring means irrational numbers. It's non-repeating. It's not repeating but continuing that. So we have to write the examples, 3 numbers, examples for irrational numbers. For example, 0. You can start with any digit. If we are starting with a 2, 2, 3, 2, 2, 3, 2, 2, 2, 3, 2, 2, 2, 2, 3, etc. Put that extra sign, then only that is showing it's continuing. Here you can see 23, first digit if you are taking these 2 digits together, 23, but that 23 is not repeating anywhere. When it comes here, one more 2, 223. That also not repeating. Next time, one more 2. So when you are writing, you can take any digit and this the same way. You have to continue that. If we are starting with 0, 5. So when you just add zeros more, 2 zeros. Here only 1 0. So 2 zeros, 5. Then 0, 0, 5. When you are writing next one, 0, 0, 0, 0, 5, etc. Or another example, 0. If you are starting with any number 7, then 0, 7, 0, 0, 7, 0, 0, 7, etc. Here everywhere you can see there no number, it is repeating. Here 0, 5, next time that 0, 5 is not repeating. 0, 0, 5 is coming. Again 0, 0, 0, 5 is coming. So not non-recurring, non-repeating. These are the 3 examples or 3 numbers. You can take any number like the same way. In place of 0, you can put 1, 2, 3, any digits here. Anywhere you can select any digit, but only the thing that you have to make it sure it's not repeating, non-repeating, and also put extra sign, it's continuing. Now question number 8. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. 5 by 7 and 9 by 11. When you are simplifying, 5 by 7 is equal to, or sorry, not simplifying, when you are dividing 5 by 7, we will get that as 0.714285. This the block is repeating. That means 714285, again 714285, it's continuing like the same way. And next, if you are dividing 9 by 11, 9 by 11, the decimal expansion of 9 by 11, what we are getting, 0.81 bar. That means 81 is repeating. 0.818181, it's going like that way. So this is the decimal expansion of 5 by 7 and 9 by 11. Now what we have to do, 3 different irrational numbers between these 2 numbers. So when you are getting the question, first you have to divide and write in the decimal form, and then you have to find 3 numbers or irrational numbers between these 2. Now consider without the decimal point, the right side. Here 2 digits we can take, 71, here 81. 71 and here 81. We know that we can take any number between 71 and 81. For example, after 71, that means above 71 and below 81. That's the way you have to take between these two irrational numbers. So when we are taking these two, for example 0.73, if you are starting with 73, so after 71, 73, then after that you have to know without repeating the same block, just add, easy method means just add 0 and then again write 73, then put 2 zeros 73, then 3 zeros 73, etc. This is an irrational number because 73 is not repeating the same way. Next it is coming 073. Another example, you can start with 75. That also coming after 71, before 81. So 0.75. Same way, you can start with any digit 0. If you are taking 0, then again 75, 0, 0, 75, 0, 0, 75, etc. One more, 0.77 we are taking. Take same way, 0, then 77, 0, 0, 77, 0, 0, 77, etc. Here 77 is not repeating. Next time it is coming 077 or 077. After that is coming one more 0 there. So it is not the same way repeating. So non-recurring, non-repeating. These are the, you can take any number between 71 and 81, 0 point, the same way you have to write, and in place of 0 you can put any other digit. If you are putting 1, next time 1, 1, then 1, 1, 1 in place of 0. Anyway, any digit you can put it there. These are the three irrational numbers, three different irrational numbers between 5 by 7 and 9 by 11. Now question number 9. Classify the following numbers as rational or irrational. First one, root 23. We know that root 23 is an irrational number. Irrational number. Second one, root 225. Root 225, we know the square root of 225, that is 15. 15 is a rational number. Next one, third one, 0.3796. 3796, that is terminating decimal expansion. Just it's terminating, it's not continuing, it's not repeating or not continuing. So terminating decimal, which means rational number. Next one, 7.478, 478, etc. 478, 478, etc. Which means this block is repeating. This we can write as 7.478 bar. 478 is repeating. So what we can do? Repeating decimal, which means non-terminating recurring. So we can write non-terminating and repeating, recurring type. Recurring, which means, here the question, rational or irrational? Non-terminating recurring decimal expansion, that is coming under rational number. Now the last one, fifth one, 1.101001, then 3 zeros, after that 4 zeros, 1, etc. Now you can see it is not repeating any particular group of digits. It's continuing like the same way. So we can say this is non-terminating, non-repeating, or non-terminating, non-recurring, which means that is coming under irrational number. Non-terminating, it's not terminating, so non-terminating and non-repeating or non-recurring, which means that is coming under irrational numbers group. Irrational number.